Continuing on with circles, looking at the arcs this time. So arcs are like the outside of the circle. If you were thinking about it like a pizza, it would be the crust. So we're kind of looking at the crust of the pizza. And we have kind of two different ideas. We've got these things called minor arcs and major arcs. And a minor arc is going to be the exact same as the central angle. So if I look at the example here, notice the minor arc AB, it goes from A to B. It's only got 2 letters. So again, this reads the measure of minor arc AB is equal to 50 degrees. And this central angle, again at the center of my circle, is also 50 degrees. So the arcs, the minor arc and the central angle are the same. We know that all the way around the circle, all the way around is going to be 360 degrees. So if I wanted to find, now this is called a major arc, and I want you to notice that the major arc has 3 letters and it includes D. So I have to go in order, A to D to B. And that takes me to point B. So if I were to try to figure out what's left of my circle, I would take the whole thing, which is 360, and subtract what was left, which was 50, and get a total of 310. So I take my total, I subtract what I knew, and whatever was left over was what my major arc was. Find the measure of each arc of circle P, where RT is a diameter. So the first question's asking about RS, minor arc, 2 letters, RS. I'm going to go from R to S. And I know that this angle right here is 110. So I'm going to go ahead and say that my minor arc is 110 degrees. Major arc RTS. So again, I got to start at R, go around T, and end up at S. Well, I'm going to look at this one and say, all right, this is everything else that I just found. So I just found RS was 110. So I know that an entire circle is 360. I'm going to take away RS, which was 110, and say that RTS is 250 degrees. Third, it says major arc RST. Now I do notice that RT is a diameter. And so I see that, hey, this is halfway around my circle. So however I think about it, okay, 360 divided by 2, that's going to be 180. A semicircle like this is, again, my central angle. This central angle is a straight line. We know that straight lines have angles of 180 degrees. However you want to think about it, but because this is my diameter, it cuts it in half. I'm going to say that it's half of my circle, which is 180. Tell whether the red arcs are congruent. Explain why or why not. I would say that in this first example, yes, they are congruent because our central angle is 80 here and 80 here, which means that this also has to be 80. So yes, that one is going to be congruent. Over here, I have 2 different circles, a small circle and a large circle. However, their radiuses seem to be the exact same line. Let's not use red, Mr. Larson. Their radiuses are the same line here, and it creates a right angle. So it's actually the same right angle, which again, if my central angle is 90, that means that my minor arc is 90. If my central angle is 90, while yes, the arcs are congruent, or the degree measures are the same. However, if I think about it, is this distance, is this arc going to be the same as this distance, this arc? No, because look at the radius here versus look at the radius here. They're different sized radiuses. So not going to be, the red parts are not going to be congruent. While they have the same degree measure, it's the actual physical line, the red arc that's being highlighted, is not going to be the same. Now, if I look over here, I'm going to say, okay, basically the same idea. If this is my radius, or excuse me, if this is my central angle is 95, then this means my arc is 95. Same idea over here. If this is 95, this has to be 95. And I know that this is congruent. Again, these are just radiuses, so those lines are also going to be congruent. So yes, this is a third example. We know that this is congruent because the radiuses are the same. They're making the same central angle. So therefore, their minor arcs are going to be the same.